All right, this is lesson 11.7, journal page 272. We're talking about dilations. And here it says, tell whether the shaded figure is a dilation of the non-shaded figure. Well, in math, a dilation means that the shape is, here's the original, the shape is getting bigger or getting smaller than the original, but staying proportional. So this would be a yes. This is what we call an enlargement. This got bigger, so we call it an enlargement. This is not an example of a dilation. This is a, 90-degree turn. So this is not a dilation. We put no, that is not. And then this one, dilation can also be a reduction, where this one is smaller than the original figure, so but still a dilation. It's just getting smaller, staying proportional though. So this is also a yes. So there are two types of dilations. Here, the shaded figure is an enlargement of the non-shaded, and here the shaded figure is a reduction of the non-shaded figure. On the next one, it says the vertices of the figures are given. Draw the figures and its image after the dilation. So we have to start by drawing the figure. Here we have A is negative 2, 2, negative 2, 2. 1, 2, 1, negative 1, so 1, negative 1, and that's it. Just A, B, and C. A, B, and C. We'll draw that in there. Obviously a triangle. I mean, hopefully it's obvious that it's a triangle. And then the scale factor is a 3, which means we go back and we multiply every single one of these x's and y's by 3. So my A prime will be, multiplying each of these by 3, negative 6, 6. My B prime will be 3, 6. And my C prime will be 3, negative 3. Just multiplying each of these by 3. Now I put it back in there. My A prime will be negative 6, 6. That's A prime. B prime is 3, 6, so 3, 6. And my C prime is 3, negative 3. C prime. I'll draw those in there. There we are. Ooh. Okay, so there's my enlargement. So it says identify the type of dilation. It got bigger, so that's an enlargement. And that was easy because when the scale factor is larger than 1, which 3 obviously is, it's going to be an enlargement. Okay? And now, if I wanted to, well, connecting my C prime and C, that obviously goes through the origin because it's this side of the triangle there. Same with my A prime and A, also goes through the origin. B and B prime, if I connect those, they also go through the origin. And that's just a test to make sure that it all worked out well. But enlargement was the answer there. Here, over here, we've got a 1, 2, 3, 4 vertices, so some kind of a quadrilateral. And I've got D is 4, 2. 4, 8 for E. So this is D, this is E. 8, 8 for F. And 8, 2. Oh, that's not. So 4, 2 for D. 4, 8 for 8 is E. F is 8, 8, and this is 8, 2, which is our G. Very good. We'll draw that rectangle in there. And then it says the scale factor here is 1/2. So nice for them to make all of those even numbers. So when we multiply each of them by 1/2, we get a integer here. So multiplying these by 1/2 to get d prime. So d prime would be 2, 1, multiplying x and y each by 1/2. E prime is going to be 2, 4. F prime will be 4, 4. And G prime will be 4, 1. And now I put those back in there. So D prime is 2, 1. E prime is 2, 4. So 2, 4. That's E prime. D prime. 4, 4 for my F prime, which will put it right there. And 4, 1 for my G prime. 4, 1 for my G prime. And when we're all done, we put that in there. Obviously, it's still a rectangle. It's a proportional rectangle. And it was a reduction because it got smaller. Now, to check to make sure that that worked out well, my E connected to my E prime, if I extend that, should go through the origin, and it does. My F and F prime, because these are all dilated about the origin is our point of dilation. When we connect all of these, they should all cross at the, that one I drew, it didn't go right on. Human error. So we'll try that again. Make sure your pencil is right on the vertice there. That's better. And then D and D prime 2 is kind of hiding in there, but there. Notice all of those points, or all of these lines connect at one point, and it is the origin there. So that was a reduction. So the first one, an enlargement, number 4. Number 5, reduction. And then number 6, it says, a rectangle is dilated using a scale factor of 6. The image is then dilated using a scale factor of 3. What scale factor could you use to dilate the original rectangle to get the final rectangle? And I don't know. We'll have to figure it out. But I'm just going to give an example. Let's just say we had a point A. And we'll call it 5, 10. And we don't actually have to plot it, but I do know that my A prime then, using a scale factor of 6, would be multiplying each of these by 6, 30, 60 would be my A prime. Well, I'm glad I'm not graphing this because I don't have graph paper that goes to 30, 60. And then using a scale factor of 1/3 to get my A double prime. So dividing each of these by 3 would get me to 10, and dividing this by 3 would 20. And they're saying, what could we do to go right from A to A double prime? It looks like we could have used a scale factor of 2. So what scale factor could you use to dilate the original to get the final? We could have used a scale factor of 2. We could have done that. Now that wasn't so bad. If you have any questions, make sure you're getting them answered. Have an awesome night. See ya!